Hi and welcome back to another chemistry lesson with Mr. Simons. Question 3, atomic combinations and intermolecular forces, November 2019. Again, boiling points, melting points, vapor pressure, etc. Right? So, November 2019, the melting points and boiling points of four substances, A, B, C, and D, are shown in the table below. So we have hydrogen fluoride, hydrogen chloride, CS2, CO2, given us melting points, and they've given us boiling points. Right? Define the term melting point. Explain the difference in the melting point between HF and HCl by referring to the type of intermolecular forces. So HF there has minus 83,11 and HCl minus 114,2. So HF is higher than HCl. Don't get caught out with the negatives. No? Which of the substances A, B, C, or D above is a liquid at 25 degrees Celsius? Alright, so that means it's melted at 25 degrees Celsius. Alright, explain why CS2 has a higher boiling point than CO2. So there, why is that boiling point higher than this one? Which of the substances above has the highest vapor pressure? So highest vapor pressure, lowest boiling point. There looks like minus 81,7. Alright, so let's answer the questions. So you can attempt to answer it. So melting point, the temperature at which the solid and liquid phase of a substance are at equilibrium. So we have to state that two phases and they are in equilibrium, 2 marks. Explain the difference in melting points of HF and HCl. So you should know when hydrogen combines with fluorine, we have a hydrogen bond. The HCl, we just have a dipole molecule with molecule, two non-metals. Right, so HF has hydrogen bonds. HCl has dipole forces, 1 mark each. We should know by now a hydrogen bond is stronger than a dipole force. Therefore, more energy is needed to break the HF intermolecular forces than the HCl. Therefore, melting point for HF would be higher than that of HCl. Which of these substances above is a liquid at 25 degrees Celsius? So CS2, it's melted at minus 111 degrees. That one is also melted at minus 56,6. That one minus 114, minus 83. However, HF is already a gas at 19,57. Alright, so yeah, you can actually say HCl or CO2. This one, okay, that's gas. So the only one here is CS2. It only boils at 46 degrees. All the others boil before 25 degrees, so they're all gases before 25 degrees except CS2. Does that make sense? So that one must reach 46 degrees before it becomes a gas. So any temperature below 46, 25 below that, it's still a liquid. That is smaller than 25, smaller, so they're all gases. Right? Then explain why CS2 has a higher boiling point than CO2. Alright? So number 1, carbon and sulfur, and carbon and oxygen. Sulfur is a bigger molecule than oxygen. Alright? So we can say CS2 has a greater surface area than CO2. Sulfur is below oxygen in the table. Remember, they increase in size as we go down. So the London forces increase with molecular mass. More energy than needed to break the intermolecular forces in CS2 than CO2. Right, so I hope that makes sense. Sulfur, bigger molecular mass than oxygen. London forces increase, more energy needed to break down. Highest vapor pressure by now, lowest boiling point, which in this case is HCl, which boils at minus 81,7. So lowest boiling point. That question we ask all the way into grade 12. Make sure you know it. God bless. Bye.